What everyone happens to be looking at right now is something that someone who I am in collaboration with we have devised up to create this little bad boy here. Alright, let me just preface this with saying that is supposed to be a blue LED. That is very much supposed to be a red one. Why that one's not working is beyond me. I'm guessing we burned it up. So what you're looking at here is a 3-part device that is actually a little more complicated than it might seem, but at the same time being diabolically simple. What we're looking at is this section of the circuit right here is the organ. Now what this would do, what this is doing is I've got a 555 IC chip right here. This is a timer. That is going to assist in making the noise, which is all hooked up with this. All of this is what actually generates the tones. Each of these buttons is hooked up to one of these resistors. And like this one, ow, my frickin' chest. Okay, so as I was saying, this one right here is connected to that button there. This button here is the second one, and it just goes, the order from lowest to highest tone is lowest to highest on the buttons. It goes like this. I apologize if I just blew anyone's ears out with that. Anyone who has any pets is probably going crazy right now. Now, what I've got going on right here, I will demonstrate in a moment. That's not important. What I've got going on here is actually a relatively simple amplifier using a 386. That's what this chip is. If I can try to show all the wiring going on underneath here. It's not the prettiest job, but it certainly gets the job done. Now, for a speaker, this actually went through various stages of development. This was initially going to be a recreation of the Squonk box, which I'll go ahead and just look up Squonk box on YouTube, and you'll go ahead and see what that is. And it's very similar to this. However, we have modified it. The original would have had buttons controlled by potentiometers so that you could continually alter the tone it makes. Here, instead of having various potentiometers, which is what this thing is, a lot of people will simply call them variable resistors, we've got some push buttons that are connected to these resistors. What the heck? What did I just connect to make it do that? I don't know. That scared me. And yeah, like I said, just goes through the buttons connected to the resistors, like I said. I mean, I think this, yeah, the LED is glowing ever so slightly. I mean, you can hardly even see it, which is kind of... They just got some 3D printed crystals here, which we just... boop. Red one's glowing nice and pretty, though. But, as I was saying, yeah, amplifier, organ. Now, what this is, let's go ahead and play this note. Now let's go ahead and turn this on. Connected by this little switch here. Now, what this is doing, if I go ahead and start moving this variable resistor here, you'll see it change intensity. Now, what that's doing is that is actually the work of this little area here, this little piece there, and that is making the LED start flickering like this. That is connected with this little optocoupler right there, that 4N25. Is that a 4N25 or a 4N29? That's a 4N25. Okay, that's what I thought. Little optocoupler right there. Now, if I go ahead and play a tone, you'll notice it has a wobble effect. And that is all triggered with this little switch here. Going ahead and turning that off, the LED remains, just goes ahead and sits still. Turning it back on, and I'm probably giving everybody a seizure right now. Sorry. But, much to my surprise, these actually added up a lot better than what I expected. what we expected was just a mess when you would hold down two buttons. If you might have seen, what I was actually playing at the beginning of this video was... So, yeah, it does actually... Okay, let's not do that again. Holy crap, my ears. Yeah, okay. Lesson learned. But yeah, it actually does blend the sounds by connecting the resistors and adding them up. Off the top of my head, I could okay, I see a 10k ohm resistor right there. So, yeah. Now, as you can see, we've got this gigantic stereo speaker on it. Right here is how we got that connected. This initially, what we wanted to do was have this on two separate sound channels to allow it to play two different tones at once. That didn't exactly work, and we weren't too thrilled with just having this external 8 ohm speaker just sitting off to the side. So, it was suggested to us, hey, go ahead and take this gigantic speaker. It's 6 ohm impedance, as you can see. I'll back up. There you go. 6 ohm speaker. Just giant stereo speaker with a board mounted to it. You can see we kind of broke the perf board right there, but yeah. It took us forever to get this thing mounted, and we also had to makeshift using Parallax Bobot parts to mount it. And we actually have a common positive and a common ground. This wire going across here, if I bring it down, you'll see it going all the way across. Going all the way across. That is, I believe, that's our positive side. And then over here, you'll see a long wire underneath here, right here. And that is our ground wire. So everything was pretty cheap, just having a positive on this side, ground on that side, or negative on that side, whatever you want to say. In electronic terms, we call it ground. Just gonna throw that out there. And we decided to be a little smart about this, and all of our chips are mounted on small IC sockets. In the case that... Let's turn that around here. In the case that... Scared me! In the case that a chip burns up, we can just go ahead and remove it here. There's our 555 from the organ. I'll just go ahead and plug it back in now because I'd love to enjoy playing some more tunes. But yeah, that is what we went ahead and came up with. I did most of the planning and prototyping. A lot of the soldering was done not by me, I will admit, but it came out pretty damn nice if you ask me.